recording this session, and I'm planning to record all the sessions to Zoom. The recordings will be available to you, and you will have a chance to rewatch the lectures, whatever we're going to be discussing. So my name is Jochen Raymond, and I have the pleasure to be your instructor for this semester. I hope you have seen my introduction. So I'm originally from Austria, so forgive my accent. I hope you still understand me well. I'm really teaching out of passion, and I enjoy doing what I'm doing, and I enjoy passing on knowledge that I have gathered over the years now, working in science, working in research. And I really want to pass that knowledge on to you, and I really want to give you a little bit of an interactive kind of insight into science, statistics, and to really give you an opportunity to also see the world from a statistical point of view. Regardless of where you're going to go down the road, you will be exposed to statistics. And I believe in that, and I think that's how I want to design this class, and that's how I want to conduct this class, and that's how I want you to expose to statistics in your first introductory round of statistics. So I understand that many of you would likely go into medicine or in psychology. And those of you that will, there's a pretty high possibility that you will be exposed to statistics to some extent and to research. And those of you that will have this exposure, I will do my other best that you will benefit from this course to an extent that you have a little bit of a starting advantage when you get to that point in your career for the first time. Good. So I have posted a little introductory video on Canvas. I would really like to encourage you to also post a response to this video and to this introduction. I really want to get to know you. I want to learn who you are, what you did, what your exposure to statistics was in the past, what do you expect from this course, where you think you will be going, and to what extent you think that statistics could be useful to you. So please respond, allow me to get to know you a little more. So this being said, so this was the first introductory words, and now I would like to go through an attendance. So this is an in-person class. I'm supposed to go through a roll call for attendance. Also gives me an opportunity to get to know you and to connect faces to names and to learn about you, who you are. Good. Rachel Berger. Hi, nice meeting you. Okay, yeah. Margot Bokor. Hi. Hi, Margot. Then we have Ashley Botnick. Hi, how are you? Then we have Zoe Botnick. Hi. Then we have Jocelyn Cohn. Hi. Jan Dennenbaum. Hi. Sophie Dubin. Oh, hi. Hi. You've been on my case already about my oversight. Thank you for that. All right. Sophie Aidan Al-Kayam. Oh, hi. Hi. Then we have Jacqueline Enganoff. Hi. Susan Fallak. Hi. It's extremely hot in here, isn't it? Yes. How are we going to remedy this? How are we going to remedy this? Does anybody know anything about air conditioning? Coming through. But I think this is all that. Does somebody know how to operate it? By any chance? Okay. Is that on the side? Is that a thermostat? It is off. Off is not good. I think that. No, that's it. Okay, that's something over there too. Is there something we can do? No. Okay, that's going to be quite a start. Okay, add that to the to-do list for next time. Okay, good. Let's continue. Abigail Goldberg. Hi, Abby. Hi, Abby. Evie Gutlev. Hi. Alyssa Hackley. Hi. Elena Higdon. Yeah. Hi. Marcella Homsani. How do you pronounce it? No? Marcella Homsani? No? All right. Shayna Sarah Huisman. Hi. Amira Eisenberg. Hi. Yardena Lipson. Hi. Yael Mellon. Hi. Did I pronounce it correct? Yeah. Mellon? Yeah. Mellon? Mellon. Regina Mesistrana. Hi. Kyla Nabatian. Hi. Kayla, sorry. Hannah Pupko. Hi. Emily Rosenberg. Hi. Sissy Schmelzer. No. Kayla Seidel. Hi. Jan Spodek. No. Okay, Sima Jäger. Hi, did I pronounce it correct? Yeah. Sima? Sarah? Okay, Sarah, okay. Oral Joseph? No. Elizabeth Zucker? Hi. Lizzie, okay. Noted. Okay, so for everybody just watching the recording, are there remote students? Do you know by any chance whether they're remote students? Do you know any remote students? So nobody has reached out to me. So those that are missing could hypothetically be remote students, but I'll find out. Okay, so I thought since this is the first lesson we have, we're gonna keep it more or less quite simple. And I just want to go through the okay, I just want to mainly go through the syllabus. I want to talk about some simple basic terms of statistics, and then I want to show you what we're essentially going to do. So all of you have a laptop on you. Is this something that is possible that you bring a laptop whenever you come to class? Because I'm planning to make this more of a laptop-centered class. I am an avid Excel user and R programmer, and both of these components will be part of this class. So you will be learning how to operate simple statistics in Excel and how to operate simple coding in R. And we will do that, and don't worry, don't be discouraged about the R. The R is going to be super straightforward. I provided the code. But these codes will be at your disposition. So down the road, you're going to do statistics yourself. You have these codes at your disposition, and you can essentially go back to these codes that I have provided you this semester, and you will profit from that, and I'm quite certain. Please also be aware that all of the lecture will be recorded. So even if you are asking a question, you will also be recorded, and this will be available for the class. Good. So the idea, so we have Mondays, we're going to talk from 6:05 to 7:20, on Wednesdays from 6:20 to 7:35. So the idea of the class is really to talk about the fundamental principles of statistical analysis, experimental design of research and research studies, and to also look into exploratory data analysis as well as visualization. So we're going to do graphs, we're going to do analyses, we're going to do hypothesis testing, we will compare groups and samples, we will do regression models where we look into association between variables, and we will also do some prediction based on these models that we develop. And we will use various examples that come from various aspects of research. They can be psychological examples from the world of psychology, or can be examples from the world of medicine. I will bring some of the examples that I'm working on. So I do research in dialysis, which is essentially a treatment for patients with chronic renal failure, where basically the renal function, the function of the kidney, is being replaced by a technological process. And the air condition is really a problem, and I think we should open this. So let's try this. Let's try with a little bit of a breeze. So maybe that was the reason why the door was open. And to start with, good. So we will learn the role of regression models. So this is the aforementioned prediction of variables. Then we will talk about inferential statistics and descriptive statistics. I will explain to you what that is. Descriptive statistics, you're characterizing data. And we will talk about this, what that means. Inferential statistics is where you analyze data, and based on these analyses, you draw inferences. You understand what these data actually mean and will predict. We will test hypotheses, and we will also learn how to postulate and how to pose hypotheses towards research questions that you actually want to ask and that you want to pursue. We will read and interpret and understand analyses that we have conducted and that have been shown to us by examples that I will have readily available for this course. Then we will interact and collaborate, and we will learn how to communicate research finding and how we communicate research questions as well as research hypotheses to various people involved in research. That can be epidemiologists, that can be statisticians, that can be physicians, psychologists, can be a lay audience. So various people that do have interest in research in some capacity. So we will talk about how to communicate with all individuals involved. So these are basically the mainstays of this course, and we will work with laptops. Did everybody have a chance to install R on the laptop? Any roadblocks? If there were any problems with the installation of R, let me know, shoot me an email or come to me after class and we're going to remedy this. We can also do this on Zoom calls. I think by now most of you are comfortable with Zoom. Unfortunately, we had to in these hard times right now, but I think we can also remedy this on a one-on-one Zoom call. Which brings me to the next topic, essentially office hours. In case there's a need for an office hour for a one-on-one check-in, let me know. We can always schedule something. I don't have regular office hours because we don't have an office here, but I want to make myself available in an online setting on Zoom calls. So I will be available whenever you need in any form, any way, a conversation on any topic. Good. So we need an office on this laptop. We need Excel. This can be a Microsoft Excel, can also be a LibreOffice, which is free of charge in case you don't have an Office package installed on your laptop. And we will need RBase and RStudio. And I hope when you say that you have it installed, that you mean both components were possible to be installed. So this is this. Any questions so far to software, the aim of the class? It will become very clear once we progress into the course what is actually meant. The textbook, I hope you all have seen the textbook. It should be available to you from the library. The edition is not necessarily as important. So if it's an earlier edition, that's perfectly fine. The material did not change as much. Some examples may have changed, but essentially it should be consistent. So we have the 5th edition, that's the one I'm working with. These are the examples that I will be using. And in addition, I will teach from slide decks that have been provided on the Launchpad. I sent out a link earlier. So I did set up a Launchpad that essentially will accompany this class. So we will do every lecture, every session. We're gonna talk through slides. And these slides are provided by Nolan and Heinzen. All the examples are by Nolan and Heinzen, and all the quizzes, including the midterm and the final, and we will talk about this soon, are basically questions that have been provided for by Nolan and Heinzen. So and this brings us then to the next conversation. So optional, I also recommend the Open Interest Statistics book from Diaz. That's a very good book, free of charge. It's an open source kind of statistics book. It's a very good statistics book, which was very good R examples. So if you're really serious about learning R, learning about statistics, this book is really a book you want to have a closer look at. It's wonderful examples, good coding, and you basically have a good head start into R in statistical programming. So data camp, all of you should have received a data camp invitation at this point. So I set up a classroom for data camp that will allow you to get a head start into R programming. R programming is something that is something I provide to you. There will be some points for you to obtain with the R programming, which will be codes that I will provide you with. So you will not have to program and develop your own codes. So don't worry about it. You don't have to become expert statistical computer programmers overnight. No worries. But I want you to have this code available, and I want you to learn to some extent what the basics of R programming entail. So this being said, data camp is something that is optional. You can pursue this course. It's usually a pretty expensive kind of platform. It's a very good didactic platform. It's very insightful. It's very educational. I highly recommend it that you really have a look at it and that you explore it and do the courses that I have assigned to you. But it's optional, and you will not be graded on it. So if you don't do it, you don't do it. But I highly recommend it. So you expected to spend a minimum of 5 hours per week on this course. You will. It is statistics. It's not. I don't know what your background is in statistics, and that's what I hope from learning from your posts on Canvas. I hope all of you have some basic statistics and the basic idea about statistics. But it's not entirely simple. So you will need to keep pace with the class because it becomes quite a bit pretty fast. So once it comes to hypothesis testing, and then we move on deeper and deeper and deeper into analysis of variance, where basically these simple terms that are in the beginning sound very, very simple, they become pretty quickly pretty complex. And I just encourage you to really try to keep pace. This being said, 5 hours is a realistic estimate that you will need to be spending on the analysis, on the course. So I have created a course that is to a large extent also online based. So you have the opportunity to collect ample points, ample opportunities to collect points. So we're going to do 3 quizzes, which you have seen the timings you have seen on the syllabus, and we're going to go through it one by one. We're going to do the so-called practice labs. The practice labs is the R coding. We're going to go through R codes. We're going to do some simple examples. I'm going to show you how to run those in R, and I will provide you with the code, and I want you to run that code and give me that output and show me that you have run that autonomously on your own laptop, on your own R, and you upload that and you get point for that. Essentially, you come with this, you come from 150 with the quizzes to 50 with the practice labs. Then I have this participation kind of item, which essentially is on the discussion board to be found. So I have posted on the discussion board, and you should have the first one available quite soon. I think it should be available already. These are videos that I have hand-selected and hand-picked that have to do something with statistics. And I want you to watch those videos, and I want you to comment on these videos. And you will be graded on, how should I say, reasonable, logically meaningful comments to those videos. You will be able to get participation points. So this is up to a total of 50 points. You get 10 of these videos, and to 5 of these, you can get a maximum of 50 out of those. So pick them well. There's some really good ones coming later on. So don't shoot your ammunition in the beginning. Just wait until the end, because there's like work on artificial intelligence coming. There's kind of great videos coming your way. So this is the participation. And then we have 3 homeworks, which essentially are accompanying the material that we're going to be discussing during the lectures. And these are basically, they're not super simple, but they're also not super difficult. They're differing, and they're basically will allow for you to kind of bring what we have learned in theory into practice. It's not that complicated, you will see. Requires a little bit of a learning curve in Excel, but we're going to practice this right. Starting today, essentially, we're going to be practicing this. So then we have the midterm exam and the final exam. And I am trying to make this very, very easy and easily digestible to you. So the following principle: Nolan and Heinzen are providing test banks. These test banks essentially contain, for each of the chapters, somewhere in the realm of like 200 to 300 questions. So essentially, I am providing with every week, with every lecture, you're going to get sample quizzes. So you can practice your quizzes. And these are non-graded practice quizzes. You can practice those ad nauseum. So as often as you want to go through these practice quizzes, you go through these practice quizzes, and you will gain knowledge from these practice quizzes. These practice quizzes, essentially, I'm taking all these 200 to 300 for each lecture questions. I put them all in a pool. And basically all these 18 chapters that we're going to be discussing, 18 multiplied by 300 are going to be in a huge pool for the midterms and for the finals. And basically I have an algorithm pick randomly questions. So these questions that you have practiced with each lecture are then basically part of the midterms and the finals. So now if you spend time on doing those practice quizzes, you have a head start for the midterms and the finals. So that's, I think it's a good compromise. It asks you to kind of sit down, go through the material, run those practice quizzes, practice answering those questions, and you essentially can then midterm and finals, you have a good starting ground to do really well on those. It's still a lot of work, but it will allow for you to really get a good head start if you really do the work. Good. So this is midterms and finals. We talked about this. This is the grading scale. I think this is kind of standard. So today we're basically just talking about the course outline. Next time we speak on Monday, we're going to talk about the introduction to statistics, research and design. Then we talk about frequency distributions beginning of September. Then there are holidays coming up, and on 9/13, on this day, unfortunately, I will be out of the country. So we got to do a remote session. I'm not even sure I can go on remote. There's a good chance it's actually going to be a pre-recorded course. So you got to be patient with me. I have some travel, which I didn't anticipate. But they're going to be pre-recorded courses. I'm going to make myself available in case anybody wants to speak about something, but I had some travel coming up for work and I couldn't really get out of it. Good. So this is this. So you have an overview of when we're going to be talking about the respective topics. We're going to speak about visual displays. We're going to look into graphs. We're going to do our own graphs. We're going to program some graphs. We're going to do graphs in Excel. And we talk about sampling and probability after a lab day. So I always have these lab days in here. So the lab days are essentially the days where we're going to do our programming and we're going to do Excel examples. Only that. So we're going to be focusing on that. So this is a day where we can also check in if there are open questions, we can talk through that, or we just focus on Excel and R. And this is really the hands-on day. Then we have, in addition to that, I also meshed in review classes. So we're coming essentially sampling probability. Then we're talking here about the normal curves, the standardizations, hypothesis testing, confidence intervals, statistical power. Then we have a review for the midterm. And the midterm essentially ends with statistical power. We have all the material for the midterms together. So this is it's good and doable. So after that, we have a lab day, and then we go into hypothesis testing. Here, the t-tests, we're going to speak about analysis of variance. Here, we're going to come from correlation to regression, essentially all the way to chi-squared, which is the only non-parametric test we're going to be speaking about. And then essentially, we have a last review session, and we're coming to the final exam, beginning of January. And yeah, so this was essentially all I had for the course outline. Any questions? Yes. Yes, there is an ebook version online. Perfectly fine, only using the ebook. I do have a hard copy, but I would work with the ebook mainly. I think that's perfectly fine. Yeah. Any other questions? Yes. Is the textbook used for assigned reading, or is it just to help us get along? There is no assigned reading, so I encourage you to read every chapter, like literally every chapter, because it is easier to digest if you follow along with the examples that they're outlining. And the Nolan and Heinzen book is actually a pretty good book. So they have good examples, and they're really explaining it in a very digestible format. So I really recommend that you really read the chapters and you really go through the examples. In addition to that, I also suggest that you really sit down and these examples that we will be doing. So I do every lecture, we will do examples. We'll do some Excel calculations. I walk through those examples. I really encourage you to also do the calculations, because statistics, you learn it best once you do it. It's 100% true. So no assigned reading, also no writing in that way. But you will do some writing by posing null hypothesis research questions, for example, when it comes to the homework. And this is important that you also understand the angle on which you have to look into null hypothesis, for example. So there's some subtleties how you would look at this and how you would phrase it. But we will talk about this in more detail. Any other questions? If not, then we can briefly talk. So I have here just a few slides. Okay. I'm not sure. Oh. No. That's not good. No. Sorry for that. Okay. And again, on the wrong way. How do I swap the display? That's $1 million question, right? How do I swap the display? That's an annoying hiccup. Sorry for that. Okay, so this is something I need to look at. Is it somewhat? Can you read it well enough? Okay, that's big enough. Everybody can see, even from the back. So, sir. So it's basically, yeah. So this is very small and hardly legible. this is unfortunately a smaller screen than I would hope for. You can, for example, you can log into Zoom. I am on the Zoom call, so you can actually get it on your screen in front of you as a workaround. But and maybe don't turn on the sound, otherwise we got some audio visual problems. Okay, so essentially what this slide shows, and I really encourage you to have a look actually at this this website. So it shows the timeline of statistics on how old these approaches that we will be discussing actually are already. So this goes literally back to ancient Egypt, ancient Greece, even ancient China, and really finds its way then slowly into the 18th, 19th, 20th century. And it's considerably interesting when you look into the history, particularly in the latest years. There was a lot of knowledge that actually has changed. And it's really a lot of fun because all these methods that we're using now on a commonly basis, they're actually not that old. A t-test essentially, which will be hypothesis testing that we're doing, is maybe not even 100 years old, and has actually a very interesting history because it was actually developed as a quality assurance approach for the production of beer. There was actually the inventor of the t-test was actually a consultant to the Guinness brewery and actually wanted to assure the quality of a beer in smaller batches. And by that, they actually needed to look into smaller samples and assure the quality of those smaller samples. And this actually brings us to the next point, because essentially what we do in statistics, we're looking at smaller samples and we're using inferences and dynamics and observations from smaller samples to extrapolate them to larger samples and to get them from larger samples even to a level of a population. And these are essentially the definitions that are important in this context. So essentially the population that you define for your analysis is based on your research question. So if you're interested in the world population, you're going to look at the world population. If you're interested in American adults, you look at American adults. If you're interested in residents of New York, you only look at New Yorkers. The population you're looking at will determine to what extent your insights and your observations are then to be generalized to other populations. So this essentially is then important to keep in mind when you do analysis in different populations. And this is why the definition of the population is actually very important for all research that you're conducting. So from that end, essentially, you're coming from populations down to the level of a sample. And the sample is a subset of this population. So you cannot study an entire population. It's impossible. When you think of every US citizen, you cannot study every single US citizen. It's not possible. You can do something that remotely gets close to that, and this is done with the census that happens every 10 years, but you cannot successfully study every single US citizen every time you do a census. So you basically, you try to get samples that you can extrapolate to your overall population. And this is why the distinction between sample and population is extremely important. If you survey an entire group, you come to the level of a census, but you can't do this with everybody, but you're trying to be generalizable. But you get, and this is the next definition, a single observation is one record. And these records build up samples, and these samples are representative of populations. And what's also important is you try with statistics, you have three mainstays and three main parts of statistics. The first is basically descriptive statistics, and we talked about this. So we do descriptive statistics and inferential statistics as the two main parts of it. Descriptive statistics are basically describing something. So they're describing every parameter that you're actually interested in. So here, for example, is the pestilence in New York City. So where you have death per 1,000 of population. So you quantify the death rate within a population. And you're describing the death rate over time. And based on this timeline that you're showing here in this time series analysis, you basically see outbreaks of certain diseases within the population of New York City. And by describing that, you're gaining insight into dynamics within the population. And this is essentially insightful, and this allows you to come to the next level where you're trying to draw inferences based on your statistics, based on your descriptive statistics. So basically, when you have then precedence approvers, where you have either disapproval or approver, you're trying to get from a sample that you have questioned and that you have inquired the approver from, you're trying to quantify on a larger population what that approval actually will be in the overall population. And you're doing that by essentially quantifying a margin of error. And this margin of error is basically determined by the variability of responses within that sample and by the sample size within your sample. So this margin of error is then basically estimating what that approval will really be in the overall population. And this is the meaning of this margin of error. And this overall is meant inferential statistics, where basically you draw inferences about a population based on your sample. So these are basically the mainstays. A third mainstay and the third major important part of statistics, and I think this is not to be underappreciated, is also the design of research. The design of not only the analysis per se, but also the design of research studies per se. So you need, when you plan prospective research, you need a statistician on board that basically helps you to understand how many subjects do I need to study that I find here really a significant difference, meaningful significant difference. And how do I need to define data collection? How do I need to design data collection to essentially have enough data points to quantify the outcome of interest? How do I essentially quantify things? How often do I measure it? How many longitudinal observations do I need? And how do I actually quantify and collect this data? So all these things are to some extent also tasks of statisticians. Also to quantify sources of uncertainty. So you have with statistics and epidemiology, you want to understand what creates uncertainty and what essentially confounds results, essentially. Confounding being to distort relationships in a way that will change your interpretation and will blur the meaningfulness of your observation and your interpretation. Any questions on that so far? Who of you actually had statistics in earlier times? Yeah? So just one? Oh, two. Okay. So there were some basic statistics that you did. And did you do Excel or did you do it by hand? Or? No? Okay, okay. So that's good. So, but there's some background and okay. Okay, that's good. That's good. Well, you'll find them probably a lot of the examples we're going to do quite repetitive and redundant, but it's still going to be interesting, I hope. So, anybody who has some background in coding? Yeah. Oh, look at that. Okay, what are you coding? Which class? STEM. Okay. Okay, interesting. All right. What did you code? Okay. Python. Okay, very good. Well, if you're going to do the practice lab in Python, be my guest. Rather than R. Who else is coding? What are you coding? Hmm? Okay, very good. Very good. Well, so I hope you're going to find it interesting, what I have to show you. Okay, so then next, okay. So we're going to do now a little example to kind of quantify what we're essentially doing. So we have here Excel. So what you really try to do in Excel and with statistics, you basically try to quantify. Can you see that sufficiently big enough? I can try to zoom in a bit. So the idea here is really, so we have here repeated data, repeated measurements. So we have here, let's say this is earnings that have been earned for whatever, for selling newspapers or whatsoever, or selling cookies, over the years, over 3 years. And we have repeated measures for each of these individuals. We have Teresa, we have Sarah, John, and Nicole. And they have earned a certain amount of money with selling those cookies. And this has changed over the years. So what you can do now, and this is where Excel is actually a very useful tool to work with data. So essentially you can always quantify formulae in Excel by essentially use the equal sign and to essentially pose whatever equation you want to do. So if you want to add, for example, now every entry of Teresa's income, you are essentially using the equal sign, and you add each of the entries for Teresa. So I'm starting really basic for a good reason, because many of you may not have had any exposure to Excel. So I'm not sure to what extent this is now super boring for you. For some of you, it may be boring. But you can essentially, with the equal sign, you can easily sum up whatever you want to sum up. If you have now you have this cell that basically is the sum of these 3 entries for Teresa. If you want to copy the very same cell now, you just have to press, so it's Command and C like Caesar. For me on a Mac, it's Control and C like Caesar for a Windows computer. You basically can, with Command and V or Control and V, you can copy this in the next cell. And essentially this is nothing else but propagating the very same formula to the second individual, which is here Sarah. So it basically, it rolls the same formula one down and does this for all the components that build up the sum. So essentially what you get by that is kind of a repetitive calculation, which is then very useful because you can do this now for each of those individuals that you have done. Alternatively, you can also do this by selecting this cell where you have the sum. Then you can go here on the right lower quadrant and you basically pull it down. And you're basically getting the same by propagating it here on the right lower quadrant. If you go here on this, you see that X is changing here. This cross is changing here. And by that, you can basically copy formula all the way down to the next columns, to the next cells, which is very useful to essentially many applications, particularly when they're redundant in nature, like this one. Alternatively, you can also use different ways of filtering data. So you can, if you, okay, let's do that. So you can always, you have, okay, this is also an important one. So you basically, you can, whenever you copy this now, obviously what will happen is it will copy the formula. Just like we copied it down, you copy it one to the right, it will copy the same formula to the right, which here doesn't make any sense because it basically, it adds up here something that is a character. So you basically, you have various ways of data cells. So you have here numeric data cells, so this is actually an ordinal data cell, whereas this is a character or a factor. This you cannot add, but if you copy the same cell now one more to the right, you essentially get now the sum of this rank earning. So it basically shifted to the right. And by that, it will also shift that target cell that it basically adds up to the right, which is useful in many contexts. But why am I showing you this? Because this is the way you need to look at this data. So you have now on columns, you see on the top row, you have what is called a variable name. So you have your name, age, year, earning, gender, and rank earning. So this quote unquote matrix essentially allows you now to look at each individual entry that is following the same outline. So you have here, each of these essentially are entries. So these are, you remember we've seen before on the slide, we have seen a single observation is called a record. So each of those are essentially records. So these are repeated records of individuals. So you have different levels at which you're looking at data. So you're looking here on a year level of individual entries of income. So here the degree of freedom or the level of at which you're looking at this data is actually an income level. You have individual income records. If you would only look into records of Teresa and Sarah, John, and Nicole, you look at the data on an individual level. So you're basically only looking at one particular individual. This is the level you're looking at. The other level you could look at, you could also just look at this on an yearly level. You could only quantify whatever had been earned through the year. So with the sum, if you equal sum, you can sum whatever has been earned in 2018. So you get here the sum for 1 year. And this was what had been earned on 1 year. So this would be the year level, so to say. So this is important because you need to understand at which level you're quantifying whatever you mean to quantify. So if you're interested on an individual, you need to understand that each individual has records for each year. If you're interested in a year, you need to understand that there are different individuals that have contributed records for each year. And this becomes important because you need to define your thinking in that way to keep focused on what analysis you want to conduct. So if you are quantifying this now for the years, you basically get yearly entries and you get 3 levels. So this is what is called essentially a degree of freedom or a sample size in that way. This becomes now interesting in the context of R. But let's stick with it first. Let's delete this again. So if we're selecting now this entire data set, let's type this again. So essentially with data, you can here again do various things with data. So you can sort data. And when you go and sort, and I'm just emphasizing this because this becomes important then for later examples. So you can now sort your data. And so you select the entire data frame here and you go on sort. Then you select here that your list has headers because it has headers, which is our variable names, right? And then we can here sort by year, for example. We can sort smallest to largest. So this starts with 2018 and goes all the way up to 2020. So it sorts by year. Then in a second, so sort by year, sorted by values, smallest to largest, these are all entries that you can change. You can do largest, you can do largest to smallest, and then we'll change that. You can also, you can sort it by age. You first sort it by year and then by age. So by that, you essentially, you create a different order within your list. So you basically, you have now 2018 and you have the youngest first and then the oldest. And this becomes important because you essentially, you want to get an overview. You want to understand your data, right? So now this is a small data set. This is nothing. But essentially, when you have larger data sets with like 1,000 entries, it makes a difference how you look at your data. And 1,000 entries is actually not that much. So you can download within seconds. You can download freely publicly available data sets that basically allow you to look at thousands of patients. So they are, for example, in the US, the CDC has conducted one of the most amazing studies, I think worldwide pretty much, is like the nutritional health and nutrition and health, the enhanced study, the nutrition and health examination study that basically allows access to data of US citizens, where they have, in the meanwhile, they have close to 100,000 patients, 100,000 voluntary subjects quantified with all parameters you could think of, from blood pressures to dietary recalls, what these individuals have eaten, various assessments, and they have so much data publicly available that you can access this data quite easily. And we can speak about this at one point with R, for example, because you can easily access this data with R, with certain packages, and you can get this on your computer. And you can do wonderful analysis with that. So for my master's, for example, I did an analysis using NHANES, and that was wonderful and great data. Yes. We're getting to that. R is a statistically programming language. Essentially, it is just like Python or C++. It's a C+ based language, essentially, that was used for programming code. So you program everything that you have on a computer. Everything of this is coded to some extent with a programming language. So R basically was a derivative of that, and they tailored it for the purpose of analyzing data. And you analyze data. Okay, let's do that now. So this is R. This is R Studio. And you have here with the console, you essentially have a statistical software or a coding software, essentially, that can allow for you to program various aspects. So you can, when you code, for example, you can code applications, you can code websites, you can code various things. So if you go, for example, if you go into any website, you have in the source code of that website, you can, somewhere you get on the source code. I forget how to get to the source code now. Tools, edit. That's not edit. Settings. No, you can basically, you get, I'm going to show you this another time, but you get to the source codes of everything that has been programmed, for example. So this is also done with a certain software that was used to program. So you have, with R, you have here on 4 quadrants, you have here the core piece. So this is the processing piece of it. So you have R Studio is a compiling software that incorporates R as a processing, as a processing and programming language incorporates this here on one quadrant and allows on another quadrant to actually save your script, which is the left upper quadrant. Then on the right, it creates an environment where you have objects in there, which is basically nothing else but a data frame. And you have then down here, you have an output section. But essentially this here, this part down here is R. And this is a programming language that essentially will do certain things that you are telling it to do. So citation. So you have various commands that will allow for you to essentially do certain things. And these things have been predefined, and these have been programmed in an earlier stage using an actual programming language into a basketball. And in an earlier stage, and these have been put together in functions. And these functions are allowing you now to approach data in a certain way that allow you to make sense of this data. So when you have here, and this is exactly the same data we have had in Excel. So we have now, and this is how you program this data in R. So you get the same data frame that we had in Excel now here in R, and it looks the same way. So it's the same data. It is presented in a different way, and it's coded in a different way. And by that, essentially, you can approach it in a certain way. And you're approaching it in a way that is different. So you can with df. So you're defining here a data frame, and you're saying this data frame is called df. And you're assigning things into df, and you make df what is called in R an object. And this object is a data frame containing name, age, year, and earning, just like we had it in Excel. So it looks the same way: name, age, year, and earning, and gender. Which I don't have in there, but that doesn't matter. And then you can access certain parts of this data frame with programming. So if you have df, and you just look at df, you get name, age, year, and earning. And with df, comma 2, and here you have a certain way, and this is data camp will allow you to get a little bit of a head start here to see that. So this is the entire df. And you can, with simple arrangements within parentheses following df, you can address certain parts of this data frame. So if you say df and the brackets, and you separate you separate that with a comma, you basically get everything before the comma stands for a specific row within the data frame. Everything after the comma stands for a specific column. So if you look into your data frame, you have here name is column 1, age is column 2, year is column 3, and earning is column 4. So if I just want to have column 4, I basically do df4 and I get all the entries for earning. If I want df2, I just get here every age entry. If I want only the first 4 entries for age, I just do 1 to 4 for row, and I do 2 for column 2. And by that, essentially, I get only certain subsets of what I want to look at. And I can do this even more refined by saying, okay, I do df, where df age equals 28, and you can by that define it, and I get now all the entries where I have individuals that are 28. So I'm applying logic to my selection, and by applying this logic, I basically get a subset, and with that subset, I can basically do now analytical approaches. So R is basically a software that allows for you to approach data in a way that you can analyze it targeted for your research question. And this is where R is unique and much more useful as compared to Excel, because it allows you to really target it, extract some certain data snippets and extract that data that you actually want to use for your analysis, and to aggregate and to put data in a way that you can analyze it for your research questions. So that was now quite rambling on what R is, but essentially it's a statistical software that basically is targeted for the analysis of data. And by the way it was designed, it makes data analysis easier than with other commercially available softwares like Excel, for example, or SPSS for that matter, or other statistical softwares. There are many statistical softwares that allow you to do the same thing. R is just much more versatile and much more useful software for that purpose. Does that answer your question? Quite extensively, I know. No, but this is basically, this is R. So we have Excel. We have Excel as a software that allows essentially easy, smaller data manipulations, and that allows to do some certain things with your data that is quick and easy. But when it comes to larger data sets, you will resort to more specific software like R. So now if you so we did this. So essentially what you do, and you have the code, you can load this code into your R that I have provided on Canvas, and you can start just running that. You will run code in R by basically putting, selecting whatever you want to run and pressing Control and Return. And Control and Return will basically run that part of the code. So now we are selecting this. Control and Return will now run that part. So this will restore this data frame. And if we now go further down, we can now select part of that, and we're running now. This is the second column. So these are the ages of the individuals. If we do the first row only, so we say in the bracket, we have everything before the comma. We'll define the rows that are being selected, and everything after the comma defines the columns. So if there's a 1 before the comma, that means it only grabs the first row. So this is what's happening here when I run this code. So this is now only Teresa, 28 years old in 2018, and her earning in 2018. So this is the first row, as you can see here, right? Then we have display all earnings. These are all the earnings, and here we have DF, again, the bracket. We have the comma, and we have the fourth column. That is essentially all the earnings. Alternatively, we can also say, okay, so we want DF, comma, and we want that variable name called earning, what essentially will give you the same result. Oops, not like this. Control Enter will give you the same result. So you can approach it in different ways, and different approaches gives you the same result. You can also do DF where the name is Sarah. You can do DF earnings, so you get the earnings from Sarah over those 3 years of observation. And you can sum all the Sarah earnings together. Sarah earnings. You can also put all the Sarah earnings in a separate object. And this is the beauty of it, because you can basically create sub-objects based on the objects that you have at your disposition. So you can take here Sarah earnings becomes, and this is that little equal sign, which is very characteristic in R. You basically do a smaller sign and the dash and the hyphen. And by that, you can assign a subset, a subselection of your object into a new object. And by that, you get another object, Sarah earnings, that is a subset of your DF. So you only grabbed name Sarah, you grabbed earnings where the name was Sarah. So you define your subselection based on the rows where the name was consistent with Sarah, and you only took everything after the comma defines the column, you only took the earning column. But it basically, it corresponds with that subselection that you have defined for the row. Does that make sense? Yeah. Essentially, you have the code, play around with it, and also do the data camp that will basically allow you to also see how to use that actually in real life. And now you can, with Sarah earnings, which contains now the 3 entries for Sarah, you can just sum this up and you get the sum. You get the sum of Sarah's earnings. Make sense? And that makes it quite easy. So now obviously these are 12 entries. Like I could just go in Excel and do what we did before, like a equal, plus, 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 and done, right? That's one way to do it. But now think about, so we do analyses in our dialysis patients in data entries of 200,000 to 300,000 patients. So now let's say you want to quantify what, so dialysis patients receive dialysis on a Monday, Wednesday, Friday, or on a Tuesday, Thursday, Saturday. Now imagine you have 200,000 patients and you want to know of those 200,000 patients what their blood pressure was when they walked into the clinic on Wednesday. You don't do plus, plus, plus. So you need something that allows you to create a subselection in a very palatable and very easy way. And this is the way to go, because by that you create a generally applicable logic that allows you to subset a larger data set and use analytical tools to create aggregated values for those subselections, and then use those for your inferential statistics. And this is why R is so important, and this is why tools that R offers to you are so important. I'm not saying R is the only software that does that, many other softwares around, but R just does it in a very good way, particularly when it comes to large data sets. R is very fast on providing these insights. Also Python. Python, for example, is even, I hate to say it, but like a little faster, but yeah. So there are different approaches to this, but this is just, it's the logic that you will learn in this course. If you follow along, this logic will help you with every other language, because the approach to it is easy and very intuitive in R, but it's comparable to other software. So I think it's a good starting ground to think in R, and whatever software you will be using down the road is like those of you that go into psychology, like you will be working with SPSS. It's just, this is an occupational thing. This is just in psychology that they love to work with SPSS. Sociology more with SAS. So there are some certain preferences. So you will see mathematics, Python, all the way, or MATLAB. So there are really like preferences within the different specializations. Okay, so this is R. Any questions on any aspects that have been discussed? Any aspects on the course per se? So I really encourage you to familiarize yourself with the syllabus, and familiarize yourself with Canvas. Watch the videos. Watch the videos. It's actually, there's now, so one of the first videos is the inventor of the spreadsheet. That's the person that actually has invented this. Because now imagine this. And imagine studying statistics, and you will see it down the road. It's like once we start hypothesis testing. Now imagine doing all this analysis, all this hypothesis testing without having a software like that. So imagine, and we will do by hand. We will compute standard deviations, but we do it in Excel. So this is not even by hand. Now imagine doing this literally by hand. So this is quite a task. Imagine accounting and bookkeeping 50 years ago before Excel. So this is yeah. Did somebody of you watch The Imitation Game, for example? Yeah. Alan Turing, this device that he invented, is like this is the predecessor of this kind of analytical approach. What he was able to do with his device, or what his device was able to do, is something nowadays is done with the simplest tools, essentially. So all of this was really a development that came out over the last years. The first computers, so to say, they filled up whole floors in experimental buildings. Nowadays, your cell phone does things which is beyond believable. It wasn't possible like 10 years ago. So the progress is just unstoppable, and it progresses in a way. And you will see some of the videos are really outlining this very well, how fast things have really evolved. You have driverless cars that essentially use artificial intelligence algorithms that essentially use those statistics we are doing are basically the basis of whatever artificial intelligence and machine learning algorithms are essentially doing. So this is regression. This is that's not the simplest linear regression that we're doing. It's obviously more advanced regression, but it's the basic. And this basis is just what determines where things are going. So this is what you're learning here is the basis of everything. All right. If no more questions, then I think we can conclude for today. Thank you for your attention, and have a nice evening, and see you on Monday. When you look here